And in today's episode, among other things, you'll see the ultimate kick. Yeah, China showed off its humanoid robot that learned martial arts, pulling off some pretty wild moves, including ripping another robot's head off. We'll also see the future of basketball, which will have robots that dunk and artificial intelligences that train human athletes. The humanoid robot with tactile hands that learned to grill kebabs in just 6 days. The United States presents its fighter jet, which is called the Ghost, that doesn't use runways and has scared the world. And China's Fire Shield, which achieved the historic capture of a reusable rocket, almost in the SpaceX style. Let's break all this down and a few more things about new technologies. Hello everyone, I'm Carlos Salvez and you're watching Incredible Reality. Robots throwing punches, kicks, and recovery moves. Some of them kept fighting even after losing their heads. And this happened during real matches that were broadcast live. This was exactly the event that marked the debut of URKL in China, a freestyle combat competition but for full-sized humanoid robots, organized by Engine AI based in Shenzhen, URKL.
Engine AI sediada em Shenzhen.
A robot called T800 was designed to have the size and weight of an adult human. As we see in the images, it is capable of performing advanced combat movements, including punches, spinning kicks, and quick recovery after falling. Equipped with posture control systems, dynamic perception, and impact absorption. It can withstand repeated impacts and maintain balance during high-intensity fights. Even after losing its head and the sensors located in it, the machine kept fighting using the control system in its torso, throwing punches and absorbing blows. And all of this happened until the end of the fight. That's a pretty resilient robot, huh? The organizers said that the incident demonstrated the structural durability, redundancy, and resilience of this robot in combat conditions. When a human throws a high kick, dozens of muscles make small adjustments almost instantly to prevent falling, to maintain balance. Replicating this behavior in a humanoid machine requires controlling force, speed, center of gravity, and grip on the ground, all at the same time. That's why, before putting this robot into real tests, the researchers transferred this training to virtual environments, where millions of attempts can be made without risking damage to the hardware. After millions of simulations, the robot kind of learns on its own how to distribute its body weight, control its leg thrusts, and regain balance after each hit. When this training is transferred to the physical robot, sensors spread throughout its feet, hips, and torso make hundreds of micro-corrections per second to compensate for any imbalance. Besides the software, the hardware also had to evolve a lot. The robots use high-torque actuators, which are capable of generating very fast and extremely precise movements. The chassis combines lightweight materials like aerospace aluminum and carbon fiber, all to reduce inertia during kicks. At the same time, impact absorption systems control the deceleration of the joints right at the moment of collision, preventing the force of the blow itself from damaging the motors and gears. Cameras and depth sensors continuously calculate the target's position, automatically adjusting the trajectory and height of the movement. Although these demonstrations are reminiscent of scenes from movies like Real Steel, the goal goes far beyond fighting. All this knowledge about dynamic balance, recovery after impacts, and body coordination can be applied to robots designed for rescue missions, industrial inspection, disaster area exploration, and ground operations. Extremely unstable, maybe even outside our planet. And, for sure, used for war. That's what humans know how to do. Okay, I've already made my criticism here, so let's move on. The better a humanoid robot can maintain its balance in the face of unpredictable forces, the greater its ability to work in environments where people would hardly be able to operate safely. The URKL 2026 tournament is part of a broader effort by China to promote robotics and accelerate the development of these humanoid robots through testing in real-life situations. Some industry experts say that these competitions raise public awareness and help to highlight technologies such as motion control, dynamic balance, impact resistance, and the mechanical components that are essential, especially under these demanding conditions. But others have warned that optimizing robots for combat could divert the focus from developing industrial and practical service applications that are meant to help us humans, right? So, what roles do you think these robots and these humanoid machines will have in our society? Leave a comment below. It really helps the channel grow. Your comment matters as much as your like, so don't forget to leave one. And of course, your subscription. If you haven't subscribed yet, take a look down below and subscribe so YouTube keeps recommending our videos to you, all right? Thanks. Let's continue now. Chinese researchers showed a humanoid robot that was able to learn in just 6 days of training how to prepare and grill delicious meat skewers, as well as stretch handmade dough in front of an audience watching all of this. Preparing food requires much more than just repeating programmed movements. Each piece of meat has a different size, weight, and resistance. The dough, on the other hand, changes its elasticity as it is handled, and heat continuously alters the behavior of the ingredients. To face this challenge, the engineers developed a system that combines computer vision, force control, and high-precision tactile sensors, allowing the robot to adapt its movements in real time. During the demonstrations held in China's Xinjiang province, the humanoid robot proved capable of assembling and grilling these meat skewers without deforming the ingredients. Its arms, hands, and fingers work in sync, while the sensors continuously monitor the force applied to each piece of food. Instead of performing rigid movements, the artificial intelligence automatically adjusts the pressure and speed according to the shape and resistance of each piece. However, the most impressive challenge appeared in the traditional preparation of hand-stretched noodles. This technique relies on identifying when the dough can be stretched without tearing. To do this, the robot uses an array of tactile sensors distributed across its hands, capable of measuring small pressure variations in various directions. This data feeds an artificial intelligence system that recalculates the movement of the arms at every moment to maintain the ideal tension throughout the entire stretching process. All this training, as I mentioned, was done in just 6 days, my friends. But this demonstration is just the beginning. Each dish prepared generates thousands of new data points about handling soft objects, motor coordination, and interaction with real environments. And this valuable information can be used to develop domestic robots, assistance systems, hospitality services, and even platforms that will compete in the World Humanoid Robot Games, an international competition dedicated to practical skills of humanoid robots. Yeah, that's something I really want to see. And it's a fact that a new generation of humanoid robots is no longer relying solely on rigid commands, but is learning directly from its own experience, observing the environment, making mistakes, and improving its movements while working. The concept is based on a similar idea to the way we humans can learn. Instead of memorizing a fixed sequence of movements, the robot builds its skill by continuously interacting with the environment. Founded by researchers led by Huster Drake, who is a world-renowned authority in robotics and artificial intelligence, the company developed a platform capable of adapting the machine's behavior as new challenges arise right on the factory floor. The core of this system lies in the so-called large behavior models, which are neural networks trained to understand not only images, but also the physics of the tasks they are performing. Instead of following predefined scripts, these models analyze the environment, calculate different possible movements, and choose the most suitable strategy for each situation in just a few moments. Together with algorithms known as diffusion policies, they continuously refine the force, torque, and trajectory of movements, allowing the robot to handle small variations without interrupting its work. Each attempt generates new data. When a task is not performed in the best way, the system uses that result to adjust its behavior in future executions. Over time, the machine becomes increasingly efficient without needing to go through lengthy reprogramming processes. It is precisely this capacity for continuous revolution that sets the new robots apart from previous generations. And the interest in this approach is already attracting billions of dollars in investment. At the same time, companies like Robot.com are also accelerating transformations with humanoid platforms focused on the robot as a service model. An example of this is the Humanoid robot, which was developed to perform different functions in restaurants, laundries, and logistics centers, using arms with 7 degrees of freedom and being able to be deployed in just a few weeks after evaluating its environment. Yeah, in this soccer World Cup, we saw that technology has transformed practically every sport, hasn't it? Sensors monitor the athlete's performance, algorithms analyze the matches, and cameras capture every detail of the movements. But a new generation of robots promises to take this revolution far beyond data analysis. On one side, humanoid robots capable of jumping and performing basketball dunks autonomously. On the other side, robotic coaches that follow the players in real time, correcting techniques and simulating opponents during training. For a long time, training equipment was limited to automatically throwing balls or recording statistics. They didn't understand the context of the game and couldn't adapt their movements to the athlete's actions. With the advancement of so-called physical intelligence, this reality is already starting to change quickly, you see? Now the robots can interpret the environment, calculate trajectories, and react dynamically to changes that happen on the court. One of the most impressive examples comes from Magic Lab. The company developed a humanoid robot that is capable of performing one of the most demanding tasks for body balance, which is making a slam dunk. To do this, the system combines high-torque actuators, depth sensors, and control algorithms that continuously calculate force, speed, and position during the jump. While the robot is in the air, hundreds of adjustments are made to maintain stability. Upon landing, another system distributes the impact through the joints to protect the motors and the mechanical structure. On another front, the Luminar Star robot follows a slightly different path. Their carrier robot was designed to act as an intelligent trainer on the court. Equipped with omnidirectional mobility, it follows the athlete's movements, makes passes from different angles and speeds, and uses cameras to analyze shooting mechanics in real time. Artificial intelligence identifies small posture mistakes, monitors signs of fatigue, and generates complete reports that help the human player improve their technique based on objective data. The result is a new training model in which robots stop being just repetitive machines and become active partners in the athlete's development. Instead of replacing human coaches, at least for now, right, as I always say, these platforms provide information that would hardly be noticed by human observation alone. And what if this monopoly, which Elon Musk's SpaceX currently holds outright when it comes to reusable rockets, were suddenly challenged by a show of strength from Asian aerospace engineering? Yeah, my friends, in a development that has just reshaped space geopolitics and shocked the world, China has successfully carried out the first controlled recovery of the first stage of its new generation of boosters. In the history of humanity, the vast majority of rockets were built to be used only once. After completing its mission, the first stage was discarded in the ocean or destroyed during re-entry itself, making each launch extremely expensive. The reusability approach created by Elon Musk, whether you like him or not, changed this logic by turning components that were previously lost into equipment capable of returning for a new mission after maintenance and inspection. In this test carried out by China, the first stage separated in a controlled way after finishing its initial flight phase. From that moment on, the challenge became controlling a huge metal cylinder in free fall through the atmosphere. Using a thrust vectoring system, aerodynamic control surfaces, and small thrusters to adjust its altitude, the vehicle continuously corrected its orientation while reducing speed. And the final moments are the most critical. Shortly before landing, the main engines are restarted to perform the so-called braking burn, drastically reducing the descent speed. At the same time, algorithms analyze the position of the sea platform in real time, and it does this by compensating for the movements caused by the waves and adjusting the engine's power in tiny increments. As soon as it touches the surface, landing legs absorb part of the impact and stabilize the entire structure to prevent any tipping over. Even though the guys used a net to help steady the whole process for now, the success of this demonstration represents much more than just a technological achievement. The possibility of reusing the first stages significantly reduces the cost per launch. And this, of course, increases the frequency of launches and strengthens the related programs. The construction of large satellite constellations, future lunar missions, and, in the long run, much more ambitious exploration projects, right? Maybe Mars? Let's wait and see, right? North American companies are developing a new generation of aircraft that are capable of operating without conventional airports, okay? They do this by using vertical takeoff and landing, combined with artificial intelligence and propulsion technology inherited from military aviation. In modern conflict, runways represent highly strategic targets. Satellites can already locate them easily, and long-range attacks can disable these structures within the first hours of a war. To reduce this vulnerability, Shield AI and AG Aerospace are working on developing a platform that can operate from much smaller locations, such as remote islands, improvised areas, and even adapted vessels, reducing the dependence on large airbases. The main challenge is in vertical flight. Unlike a helicopter, a jet needs to control the enormous forces generated by the engine while it remains practically stationary over the sea. For this, the project uses a vectored thrust turbine based on the old Avian program, originally developed for testing with the F-16s. This system continuously directs the engine's gas flow, making small adjustments at very high speed to maintain stability during takeoff, hovering, and landing. All this capability is powered by the F-110 GE6 engine, and this is one of the most well-known engines in American military aviation. In addition to providing the necessary thrust for flight, it produces enough energy to power radars, sensors, electronic warfare systems, and other onboard equipment. The design also includes internal weapon bays while preserving very important low radar signature characteristics. But perhaps the most important component is the software. The HiveMind system, developed by Shield AI, allows the aircraft to carry out part of its missions in a highly autonomous way, navigating even in environments where GPS signals are degraded or unavailable. In other words, my friends, instead of relying exclusively on constant commands from the pilot, artificial intelligence can do this autonomously, assisting the entire decision-making process and adapting the aircraft's behavior to environmental conditions. And pretty soon, it'll be handling the weapons too, right? For those who have ever changed a tire on the road, take a moment and imagine driving without ever having to worry about flat tires again. Besides losing pressure or even needing to carry a spare tire. It sounds like a futuristic idea, I know, but it has just taken a big step in that direction and is already out on the streets, you know? Since the invention of the pneumatic tire over a century ago, practically all vehicles have depended on internal air pressure to support their weight and absorb irregularities in the terrain. The problem is that this same pressure also makes the system vulnerable to punctures, cuts, and blowouts, and, of course, gradual loss of performance. Bridgestone's proposal is to completely eliminate this limitation by having the tire's own structure support the entire vehicle. Instead of air, the air-free uses a network of curved spokes made from highly elastic thermoplastic resins. When this tire comes into contact with the ground, these elements deform to absorb impacts and then quickly return to their original shape. The weight of the vehicle is no longer supported by internal pressure and is instead distributed throughout the entire structure of the spokes, allowing the assembly to maintain its strength even without any type of inflation. In addition to durability, another highlight is sustainability. The materials used in the internal structure are recyclable, and the project was developed specifically to reduce tire disposal caused by puncture-related damage. The first conventional applications are aimed at light electric vehicles and urban fleets, where eliminating maintenance stops can represent a significant saving in time and operational costs. Despite the advances, there is still a very important challenge in all of this. At high speeds, the heating caused by the continuous deformation of the structure can compromise the efficiency of the system. That's why engineers are still developing new materials and thermal dissipation solutions to allow this technology to also be used in passenger cars and high-performance vehicles. If you like this episode, you know what to do, right? Leave your like, check your subscription down below, and if you can, click on one of the 2 suggestions on your screen, and let's go to the next video. That really helps me out, okay? It's called Session Time. If you're watching on TV, even better, okay? Click here. I'll be waiting for you over there. Real quick, okay? Bye for now and see you next time. Actually, see you soon. I'm not going to say bye-bye. I'll say see you soon and then I'll say bye-bye. I said bye, damn it. See you soon, right? Not bye, scratch that.